Good morning, Mr. Anderson here. I know I was supposed to be live with you today, but I need to be at home, so this is going to have to suffice. So lesson 12 on Friday, we talked about a claim that the restaurant chain made about 82 French fries being in a bag. We looked at the data from 3 bags, and of course you could have collected it in a variety of different ways. But most likely was a count on bags that you buy. How many were needed to be an accurate representation? That's a topic for another day. We talked about the medians of the top half and the bottom half of the data for each of the 3 restaurants. So the median of the top half is going to be the upper or the third quartile, Quartile, and the median of the bottom half of the data, that's the lower or the first quartile. So for restaurant A, 87.5 and 77, 83 and 76. For B and C was 84 and 78. The difference between the medians of those 2 halves is called the interquartile range. So interquartile range, or IQR, is the new topic for today. We're supposed to find the IQR of each. So pause the video, find each IQR, and go from there. So we just talked about the difference, right? So you got to subtract. 87.5 minus 77 is going to be 10.5, or 10.5 for restaurant A. 83 minus 76 is 7, and 84 minus 78 is 6. So the smallest IQR is restaurant C, and what that means is that you're most likely to get a bag of French fries within that typical range. Okay, so there's a smaller range of fries. You're not going to get a bag with many fries. You're not going to get a bag with very few fries. You're always going to get a consistent amount from a restaurant with a smaller IQR for bags of fries. So moving to slide 2, says the median of the bottom half is called the lower quartile, Q1, and the median of the top half is Q3. About what fraction of the data? Well, and then mark the quartiles on the plots below. Pause while you do that. Okay, so when you have 26 bags of fries in restaurant C, 13 above and 13 below the median. So count 1, 7, 8, 9, 10, 11, 12, 13 is right here. So this is the median value right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median value is actually in between these two values. So 13 above and 13 below. So then half of 13, that's going to be 6.5. So 1, 2, 3, 4, 5, 6. So right here, give me 1, 2, 3, 4, 5, 6, 7. So let's go with this value right here being Q1. So there's 7. So this value, 1, 2, 3, 4, 5, 6. This value right here will be Q3. And half the dots are going to be between Q1 and Q3, because we split it up into 4 quarters, right? So we got a quarter and a quarter and a quarter and a quarter. Quartiles. That's where it comes from. So 18, 9 above, 9 below. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 above, 9 below. 1, 2, 3, 4 above and below that. So there's Q1. 1, 2, 3, 4 above and below that. Check that. I need 4 above and 4 below, so I need the 5th one. It's going to the same value because it's in the same place in the number line, but there you go. 20, so 10 above, 10 below. 1, 2, 3, 4, 5, 6, 9, 10. So halfway between these values, there's the median. 5 above, 5 below, because there's 10 on each side. So there's Q1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 above, 5 below, that's Q3. When there's more than one value where the quartile is, then of course that value is just a quartile. But in a situation like here, I'd average those two, or I'd average these two to find the median for here. All right, moving on. Third slide. So to create the IQR, you've got these steps. Order, find the min and max, find the median, find the lower and upper quartile, and then calculate it. All right, go through in that step. Looks like it's already in order for you, but then go ahead and answer these questions. I'll pause the video while you pause your video while you calculate. All right, so we're something's happening here that I talked about on the last slide. So when we go to put these in order, already done, easy peasy. The smallest was 1, the biggest was 17, the median 10. I needed to count 17 bits of data, and then I know that there are 8 smaller and 8 larger than the median. If you wanted to do the cross out the smallest and the biggest and the smallest and the biggest and the smallest and the biggest until you find that one value or 2 values that you average in the middle for the median, you can do that. I like to keep my data clean because I'm still using it to find the upper and lower quartiles. So I got 4 bits of data below the bottom half, the half of the bottom half, and 4 above. So I need to find the median for the lower quartile. So halfway between 4 and 6, Q1 is 5. Now, 15 and 15 are both the values here. So Q3 is 15. So the IQR, 15 minus 5, is going to be 10. And we're always going to have a positive value for the IQR as well. Okay? So going on to the fourth and final slide, when should you use the IQR? So the data for the 2012 salaries for the Lakers are on the plots below. The vertical lines on the top of the plot show where the mean plus and minus the MAD. On the bottom shows the median with the IQR. So which interval will do a better picture of the typical salaries? So we talked before. What do you do when the data is really spread out? When the data is really spread out, especially when you got Kobe's salary up here, and you got these big chunks of data here. When the data is really spread out, the mean does not do a good job of giving a typical value. The median would give it very typical value. You see this? I've only got 5 salaries above the mean. I've got half the data above the median. I've got half the data in between these quartiles. I've got all but 3 plus or minus the MAD. So that doesn't give you a typical value. That just stretches it out. It gives you more things. So the IQR is going to give you the interval that's better. The interval that's better is going to be the IQR, because the median would be a better typical value. Sorry I couldn't be with you live today, but gut pressing matters. So thanks for your understanding. Have a great day.